work incrementally to start thinking of what we need to do to make that a reality, to make this initial proof of concept a reality. And that's why I added those agenda items on GitHub, which is in particular, what kind of format we should use, which kind of client we should use, and all that stuff. And also, we talked with some Portal people that I think are in this call. That could also give us an idea of how Portal could facilitate 4.4s, and yeah, that stuff.
I also just want to say really fast that I started recording this call. So if anybody's not comfortable with being on a recorded call, I would go ahead and drop off now. Yeah, thanks for that info though, George.
We may want to wait like 1 more minute. I think people are still filtering in. Hey, Mikhail.
Hello.
Because Piper said he was going to join, and I'm not sure if anyone here is someone here else from the Portal Network. Because I do think we could have like a pretty helpful conversation there, just to like at least, I think for me it'd be helpful to hear more about how they see that fitting in here, because I do definitely think that we want something like the Portal Network to serve historic data, and so it would support 4.4s quite nicely.
I'm actually working on a Portal Network, but it's libp2p based, so not directly with the Portal group, but maybe an alternate solution.
Cool. Yeah, I actually think someone showed me what you're working on a separate call. Some of the we are working on some of the like client stuff and talking about the Portal Network. And then I think well, separately, cool. Good to see you.
I mean, also, I think regardless of Portal Network, IPFS would be another place to store historical data as one of the easy backends. Like torrents is the obvious one, IPFS is another obvious one. So that's another useful thing to have, expertise in IPFS.
Right, which you're our IPFS expert, right, George?
Yes, since last night, I'm now an IPFS expert.
Okay, speaking of, do you want to walk through the agenda items that you put down here, George? I think we can start moving ahead.
All right. I mean, look, it's a rough agenda that I made up on the spot. So I think like the way I started thinking about this is that we should think of how we expect nodes and clients in the future to use historical data. Like, okay, let's say that we have a file that includes historical data, perhaps per year, per month, we don't care at this point, and we get this through torrent or Portal Network or whatever. How do we want clients to consume this data? So for example, the most obvious thing to do is have an import functionality and import that into like the local state of the client and have the client manage this. Another way that I started thinking about is whether we want to have like, be able to use the historical data archive files for queries, like their databases. I'm not sure if that's worth having. I think it might complicate things, but if this is also something worth considering, like how we expect the UX to be. And then, the next agenda item is, given the UX that we want to support, how do we expect the format to be? Like, what kind of encoding do we want? You guys are writing stuff, but I'm not monitoring it while I'm talking. So if this is something relevant, feel free to interrupt.
I think we're
like what kind of encoding?
Side conversation.
Okay.
Sorry, you're good.
No problem. So what kind of encoding we want from the historical archives? Like, do we want a binary encoding? Do we want to be, it's going to be S1 data, so RLP stuff? Do we want to use, I know that some clients like Besu have RLP export function. How does that work? I don't know. So do we want to just use that? Do we want to, I'm not sure what we want to do here. So that's the second agenda item. And the third is, towards moving toward the proof of concept thing, decide which client we want to target first. And as someone mentioned, in theory, we just need one export functionality, one client to export everything, and we want all the clients to be able to import. Like it's not necessary for all clients to be able to export, since we just want one good export and everyone's gonna use that. So yeah, that's the agenda, and then have some discussion with the Portal Network group about how that would look like and how integration would look like and that stuff. Does anyone think we should add something to the agenda or subtract something?
I think that makes a lot of sense. I think the only thing I would add is just like an initial question of what do we think the biggest blockers for 4.4s is in general? It feels like to me the biggest sorts of blockers are just going to be convincing people that this is a good thing to do. I don't feel like any of the technical discussions that we're like looking to have are going to be things that we don't have answers to, or we don't really have things that might solve those problems. It's more just by shedding what the best way we think is to do it. I don't know if anybody disagrees with that sentiment. Generally, no.
Yeah, I don't disagree. So then the question is, what can we do to convince people, right? And I think that's where then we like, okay, let's build prototypes. Let's get like well-known industry players on board, all of that sort of thing.
Yeah, okay, that makes sense to me. Mikhail?
This is related. I'm thinking about the amount of time, or the size of the period of time for which the history retains, and retains under the guarantee that it's stored on the nodes in the network. Probably this 1 year is too much if we want to increase the potential size of a block, but potentially increase the size of a block. I've been doing some very rough calculations, and if we have like what is the maximum size of block? Currently is 2 megabytes, right?
So is it really 2 megabytes?
The size of the block with current gas limit, the max size of a block is a kind of 2 megabytes, right?
Okay.
And if we have this, like, let me do, it's going to be kind of a terabytes of data for 1 year, right? If we have this kind of blocks. Of course, we will not have every block a size that big, but
yeah, that's fair.
So yeah.
Yeah, I mean, I guess the question then is a little bit, if we make a decision on this time period, like, how difficult is going to be to tune that over time? Is this sort of a decision where we're going to say, here is the period in which you can we're going to guarantee the clients will maintain that data, and then in 6 months or 1 year or something, some time period we change that? Is that going to be a really difficult thing to do? Because I'm like a little bit worried about starting out with a lot smaller, like 3 months, because now that's definitely a different guarantee than some people might be used to, since we're moving into this new world where you expect to have all historical data, and now you don't have as much of it. And going from all to 3 months is a little bit bigger of a jump than like all over 1 year.
By that, you have the assumption that there are use cases that use historical data from 3 months to a year, that there are more of those use cases than use cases that use historical data from the entire history, basically. Like recent history is more important than less recent history, right?
Yeah, I mean, I definitely think more recent is more important, and it's not clear to me where it starts becoming like exponentially less important, if it ever does. But I would guess that there are still a fair number of people using things between that 3 and 12-month period, and the less people we can upset with this change, the better. So I'm just trying to figure out, like, is this a decision that we're about to make that's going to be very difficult to change and tune? Or is this something that is okay to tune?
I think it's okay to tune, but also in terms of like de-risking this, because it is such a huge change, it makes sense to say, yeah, start with something very big where you almost kind of don't notice it. And then once we have it working and we have all these other methods and people feel comfortable like going to torrent networks to get the history, let's say, things like this, then we can say, okay, let's ratchet it down to like 6 months. And eventually there's going to be, there's going to be some upper bound on like the consensus needs this much history to do anything. So like, it's going to be a certain amount of time that we can probably go smaller than a year if we need to.
What are most people expecting the weak subjectivity? How far is the weak subjectivity checkpoint expected to trail whatever the head is?
So right now it's embarrassingly small. It's like 14 days, and we want this to get bigger. But like I don't think it will. Under the current model, I don't think it will ever get bigger than like say 8 months or something. So it's true. Like one fundamental thing here is that the prune needs to be bigger than the weak subjectivity period, but I don't think that's going to be too big anyway, as long as like it looks right now.
Yeah, I mean, I think that, if we cut it down from 1 year to 6 months or something, that would probably be okay. I think 1 year is generally okay at this point in time. It's just a matter of, after the merge, are we going to do something like 4488? That's to me where I think that the historical data will start growing really quickly, because it's just think it's unrealistic for us to have consistent 2 megabyte blocks, because that's assuming 30 million gas is used. So realistically, it's closer to like under 1 megabyte. And then for the most part, we're not pushing 50-60% of rollup data yet. So that's still a ways out where we're seeing that much block growth. So if we do end up in that world where we're starting to have really cheap block data, then we should seriously consider. And so I guess it's a matter of, do we think that 4.4 is not going to become useful until the end of next year? In which case, we should probably just start planning with the intention that there is going to be a mechanism that reduces the call data cost significantly, and we should set the pruning period to be relatively small.
We're even trying to do 4488 before the merge, if possible.
I think that's probably won't happen at this point.
Okay.
I think Tim said he talked to a lot of client devs and people want to focus on the merge, and that's totally understandable. I think we should focus on the merge.
Okay.
So I don't think 4488 will happen before the merge anymore, which kind of gives us a little bit more flexibility. With 4.4s, we can just spend a little time focusing on that rather than trying to, combine them, do them at the same time.
So just a bit of the mental model I have is that, like, I don't know if it makes sense for this call to bike shed between 1 year, 2 years, 6 months, like do this
totally
judging. However, like I think the mental model is that 4.4s should guarantee that clients can fetch data to do weak subjectivity sync over the P2P network, but over time they will not be guaranteed to fetch any other data. Like potentially if we start shrinking the period, they will get for a weak subjectivity sync, but anything else they want, they might not get. And if clients start working towards that assumption, we can start with a big thing like 1 year, but then we can start shrinking and more mechanisms will come that this will be easier for clients. I don't know if this makes sense as a...
Yeah, that seems fine to me. So I mean, I think that we can close that sort of question and talk about bike shed another time. So that kind of leads us to the question you asked, though, is how will historical data be consumed by clients? And the way that I've sort of been understanding this is I think the ideal world is that it's still built into clients. It's just you not using the dev P2P protocol for the most part. And so, and it depends on exactly what the solution is. Maybe we don't, if it's BitTorrent, we don't want to tie that into the client. That should be something that we just download, out of band. But I think that if we are having a solution where it's just a list of mirrors that a lot of institutions or other people are providing, that's something that very well could just live within the client, and the client just attempts to download the blocks from those server lists.
So are you imagining though that a client then has all of the code to process all of the history forever? Or is it
No,
separate
I'm not,
from quote a
I'm not
client?
necessarily, yeah, I'm not necessarily anticipating that. I think that like A, it's decision of the client if they want to have that code. And then B, I was thinking this is more in terms of the orchestration wrapper around potentially multiple releases, just so that you don't have to just go acquire those yourself and deal with the raw block data. But I think like in the beginning, it's unlikely that clients will start removing old code immediately. And so having a simple way of allowing people to continue doing that is relatively helpful. And I don't think it's a lot of overhead.
Yeah, that makes sense. Is that something we feel like we should try and build out in terms of prototypes? Is this shim client that can process history since the beginning?
Probably. Yeah, I think that the thing is, I don't know when that software would come into play. Like, I don't know, maybe Marius could say when, because it's not important until clients say, we're not going to support Frontier anymore, or we're not going to support pre-1559 blocks. At that point, then we will need additional software. So if, I don't know, Marius, is that something you guys have discussed? Like if we do have the ability to prune historical data, will you start removing those old code paths? He may not be available. I don't know. I mean, I guess like you guys tell me how important you think it is. Like, I think it is an important piece. I don't think that it's a question of whether it can be done. It's just engineering work to do. And so to me, it's like kind of important to determine, is that something on client developers very soon roadmap after 4.4s? Like as soon as 4.4s is, is able to make the data available, they say, let's just start getting rid of stuff. Then I definitely think that should be a focus. But if they're not anticipating on removing that functionality until 2023, then I think we could just focus more on this data format and then retrieval mechanisms.
So just on the original question to understand a bit more. So let's say that I got the archive file from wherever, like list of mirrors or whatever. So I have an archive file that contains, I don't know, blocks from the past 4 years, and I import this into the client. Does the client need to, like, I don't know, run all the EVM and do everything? Or does it just like trust the blocks and provides them through the JSON RPC API? What does it have to do to import them? Like, how does the UX and logic look like there?
I think
it
it
should be
depends
able
on.
to. Oh, sorry, go ahead.
Go ahead, Berto.
It should just be able to check it through hashing. And we would add one accumulator that commits to all the previous history.
Okay, so it doesn't run like all the transactions and it doesn't do the entire thing. It just does some hashing to establish ground
caveat
truth.
is it depends a little bit on what artifacts you want to be able to have. If you're trying to build up an archive node, you would want to run all of those so you can generate all the intermediate states or the state diffs. I guess like that could be part of the download, but I guess that's like a question too, is like what exactly are we promising to make available? In my mind, the bare minimum is just blocks. Like, I mean, that is the thing that we have to provide, is all the block bodies. And then potentially we might also make available all the receipts. But then you start moving into this realm where it's like, should we also make it possible to download any historical state? And I think that would be where I would draw the line, is that would not be something I would want to provide, is providing historical state tri data. And so that would be things that that if they wanted that information, those artifacts, they'd have to generate themselves.
And just to be clear, the idea with having the receipts is that you can then verify the receipts route committed to in the block.
Yeah, exactly. Yeah.
Yeah. Okay.
And the receipts are 80 gigabytes, so it's more manageable than storing a lot of historical tri data.
That's true.
But
Yeah.
I don't have it, like, part of me would just say, let's just serve block bodies, because you can generate the receipts from the block bodies. And that to me feels like it's a little bit simpler, less data. Anything that we can make this simpler and less amount of data, I think we can get more people on board with to serve that data. And I think that creating the largest pool of people serving that data is important, guarantee.
Yeah, Marius just said in chat, blocks receipts and then snapshots every so often, right? So it could be like the state snapshot at the 1559 fork, things like this. Sounds like a good idea.
What's the use case for the snapshots generally?
It saves a bunch of work if you can trust the state, right? And then you do want to make an archive node, but only from fork A forward, right?
Yeah, that's fair.
So I think Geth already have some import functionality. Can it already import block bodies and receipts? Are we like
I think it just
done
imports block RLPs. So not receipts. So it would just go ahead and generate that themselves. I think all clients support import subcommand, or most clients support import subcommand that takes the block RLP body.
So is that like saying that the import functionality is already done and we just like, is this good enough for us? For in terms of block bodies?
Yeah, I would need to look a little bit more and see the exact way it handles block bodies and how it handles a large amount, like millions of block bodies. I think it's generally okay though. Like you give it mainnet genesis and all the blocks. I don't see why I wouldn't just go ahead and build the chain exactly like you provided it. But the question is, do we want to do RLP? And I think we should look at using SSE, to be honest.
So what about like block 20?
Block 20?
Just like a random very old block, like, because well, yeah, either way, it's like I don't think we can get rid of RLP on this front, because like what would that look like? I mean, I guess you could define a separate SSZ schema.
Yeah. And
then it's fine. But the thing is, to like interpret that data, like the shim client or however we want to call it is going to be, like there'll be RLP routines, right? So that's an open question, I think.
So I think if we go the SSE route, we won't actually end up getting rid of RLP. We'll end up with RLP and SSE, because you need RLP to be able to do certain types of verification.
Yeah.
And so the only compelling reason that I would say for using SSE would be to have the large scale Merkleization, which allows you to have a single hash that identifies a huge blob of this stuff and lets you get at individual components of it. And I have no idea if that's compelling or not, right? Like it's there's other ways to accomplish that, right? But we don't have any SSE hashes in our protocol for execution chain, and so like we don't have the right hashes to be able to verify SSE objects. So everything would have to be converted into their RLP objects before you could actually verify them. So I don't think that there's a big win there. At the like getting rid of RLP layer, the only win I think that makes that compelling is something that just makes SSE add features, but we don't actually get rid of RLP.
Can I comment on this? So
Yes.
I agree that for encoding, we definitely stick with RLP. just because it's used everywhere and it's difficult to remove at the same time. However, the commitment, the part that merkleizes or hashes the data, we can have both, because we only end up having one 32-byte object at the very end. And then the schema, like how do you commit over all of the data? There can be many of them. And once we have these well-defined snapshots of historical data, you can just compute each of these different versions of it. And the data is the same, as long as there's some software that can reconstruct and recompute the commitment, then it can be used for whatever use case you need that form of commitment for. So
So
stick
then I
with
think-
RLP and define the hashing schema as something that can be replaced.
Yeah, I mean, I think RLP makes sense where it already exists. My question then would be, are there, like, can we actually think of use cases today where we'd actually need commitments like this to the history? Because like what we're saying is there'll be some like year-long archive of the chain, and then we'll merkleize it and get some root. Is that helpful to anyone?
Can anybody tie this together in a cohesive thing? I know that there's one thing being talked about, which is making large, the first million blocks, the second million blocks, right? Is that kind of what we're talking about here? Is taking a million blocks, bundling them up together as a single giant chunk in some format, having a single hash that identifies all of that, and then what? Are we serving them from places? Are we making a torrent? Is this a new protocol?
Yeah, so I don't think that we've, we're hoping that there's many different ways of accessing that data. The way I've just been thinking about it, just in simple terms, like to me, that's a black box, is how to access the data, and we're discussing different ways. Portal network is one way that I think could be able to access data, where you just request, like, I want these blocks, and then you get the blocks. The way that I think about it, just in the simplest terms, is that, there would be a list of mirrors of servers that are providing all of the blocks. They've just elected that they would provide them. They post on some smart contract saying, here's my server address, I'll provide the blocks. And then I could just go down that list and request the blocks from that. The torrent is also like another potential option, but I'm thinking about it like in the most simplistic terms in that sense. I don't know about the bundling of blocks together. This is something that I'm not sure about. Like, is there a value of taking some number of blocks and then committing a single hash to all of those blocks? Because it feels like I am going to need to download them anyways and make sure that they are in a chain.
Reduced number of requests that need to be sent is a benefit there, right? If somebody is
For sure,
doing a
yeah.
sync of a million blocks, then having to make a million requests versus a million divided by 20 or a million divided by 50 or whatever it is, right?
Totally agree with that. I think I'm more getting the point where you were saying that there would be like a commitment or some sort of hash to authenticate those blocks against. Is that something we would want in addition to the authentication that already exists of the headers?
I think that type of commitment across a large scheme of blocks is only useful in the context of a client that is choosing to download the full history and re-execute it.
Marius, your audio is cutting out pretty bad there. I don't know if it's better now.
So sorry.
There you go. Okay.
I think since we have the header chain, I would prefer having them accessible by header. We can always sync the header chain and know exactly which header was at which block, at which height, and or which block was where, and we can just fill the header chain from the torrent. And like either like, yeah, I would prefer having it accessible by hash. So we know the block hash, and we need the block data for that. And once we have the header chain, we know exactly which if the data that was just sent to us is correct. And you can yeah, you can build optimizations on top of that as much as you want to, by saying, okay, I want, like, I'm not sending a single header request, but I'm sending like the state from here to here, and please give me like all the data, and you can always check it against the header chain.
Yep. Okay, makes sense. I guess like the last thing I wanted to say on the encoding topic is, yeah, we have RLP, and yeah, it's, very prevalent across the execution layer, and it's going to be more work to use SSZ. But I think if we're trying to make this world where we do transition away from RLP at some point in the far future, we should just stop building new things with RLP, even if it's a little bit harder.
So if the goal here is to get rid of RLP, then we have a deeper problem, because if you want to verify the block body, you need RLP, because the transaction tree uses the Hexarray Patricia tree, and the Hexarray Patricia tree uses RLP. So like RLP is still buried deep in there, because in order to take a block body and verify it against the header, you inherently need RLP to do that.
How about we keep RLP for just the existing types, but then the data structures around it, for example, those that combine blocks or combine headers, those should not be in RLP. Is that reasonable?
I don't think I quite
Right.
understand.
Yeah, can you say that again?
So we have all these legacy types like transactions, state, block headers, and so on in RLP. We can keep those in RLP, but all the additional types we define for this EIP could be in a different encoding, like SSE.
What kind of types are you thinking about for like the verification?
For example, when we have a series of block headers, like a long set of block headers, like 1 million block headers, how do you encode that group?
So
RLP is one way,
uh,
but we could start moving to something else there.
so Proto, is the suggestion here that, so maybe just as a straw man, our data format is block headers chunked in chunks of 1024. And so we take the first 1024 headers and we put them in an RLP list with a max size of 1024, with the element type being, right, byte lists or yeah, byte lists. And so, right, the data structure for the bundle of block headers is RLP. Inside of that, it's RLP encoded string. Sorry, I said that backwards. The data type for the bundle of block headers is an SSC data type, and inside of it are a bunch of opaque RLP strings that represent the encoded block headers.
That would be a good example, yes.
I'm still not sure that I understand the use case for bundles, other than for clients that want to re-execute the full chain, which is a totally valid use case. I'm just not sure that we have. I'm curious what the other use cases are.
Which part
What's
of
the alternative
bundles?
to bundles?
All of them.
Like, to me, when we say bundle, we're just saying like there's 1 million blocks, and then yeah, I guess I don't understand.
I think paper means why are we chunking? Why not just everything at once? Like, why are we saying there's chunks?
Just minimize.
When
Yeah,
does someone,
maybe.
when does someone want like blocks 1 million to 2 million? Like, what is the use case there?
When does someone want block 1,472,000 whatever in the past?
When you want a specific block, it's because there's a transaction in it you want to look at, or there's a receipt in it that you want to look at. That's the individual block use cases.
But you need to authenticate that header. So
the authentication can be done with an accumulator that doesn't have to contain all of the data. And that's something that we can,
okay,
like,
yeah. I guess that is something that we haven't considered much, is these like on-demand requests, which I think is very different from how you think mostly about Portal Network. I think a lot of the discussions we've had so far have focused on you are going to just download all the blocks because you want to have some sort of client with a header chain running. Do you think that that's something that we should start considering more? Is it if somebody is trying to request this historical block, they want a certain transaction in it, we should have facilities for them to do that? Or is that out of scope for 4.4s and that's something they should look at Portal Network for?
Well, I don't know what people intend to use this for. So what I would intend to use this for would be for on-demand retrieval of individual data, because the reason that clients are ditching this data is because they don't want to hold on to it, right? Because it takes up a ton of disk. So if a client wants to fetch an old transaction from an old block and everything's bundled up, then it's got to download 10,000 blocks to get at one transaction. That's not great.
Can we please separate authentication of data, or like the commitment to the data, separate from the encoding? Because if a client asks for one piece of data, we can have a different encoding for the response than for the encoding of the local storage of like the full snapshot, or a snapshot divided in chunks, or whatever it may be. There are two different things here, and the authentication of data, we can have many different commitment schemes, and we can optimize for the user that requests the data. And that can be different than the optimization for the rotation of the snapshot, or like the how we collect the full data somewhere.
Yeah, it sounds a bit to me like we're mixing this idea of like the history from like, yeah, I want like one block in history. For me so far, 4.4s is about we're passing around like chunks of a year of history at a time. And it's not so much like the question of how do I get one block from 3 years ago is different than how do I get the snapshot from 3 years ago. And we can have a conversation about where that boundary is. I think the less scope we have in 4.4s, the better for this specific EIP.
Yeah.
So if you want to constrain the scope, then individual retrieval is a good thing to wipe off the table and bundle these up in big blobs that are of some, arbitrary but reasonable size. And all that we're focused on is archive node style re-execution of the full history. Yes?
So
No?
Almost.
That's
I would say the commitment to the full data can still also serve individual requests. Like it could be an efficient way to
Sure.
exactly figure out that this one smaller piece is correct, that it can be authenticated with some Merkle proof type of thing with the larger commitment or for all of the data. That we should focus on getting the imports right, because we're trying to remove all of this data from the default node.
So I think that if Portal Network was finished right now, then I don't think we have a need for like this other thing that we're talking about right now for 4.4s. The issue is, of course, Portal Network is a much harder problem than here's a torrent with, the last 7 years of history. Like a torrent with 7 years of history is something that we could throw together, in weeks. Portal Network is something that will take months, years, quarters to build. And so I think that maybe the question I have for Piper is, how far away is Portal Network from being able to serve all of history? Like, is that almost done, or is that still your?
Yeah, I have a decent answer for that. We did roadmap planning last week and looked at what's coming. We've shifted priority to History Network over from State because of 4.4s and because of the immediate demand. I think that it is reasonable to expect us with no additional help to have a version of the History Network that serves all headers, all block bodies, and all receipts from history with some level of reliability by the end of by the end of next year, and with a like functional prototypes and proof of concept stuff showing up in the 6 to 8 month range into 2022. So, and that has the ability to be accelerated with additional people getting in on this. But it's probably not gonna, it's not gonna be 2 or 3 months, right? We're still looking at Q2, Q3, Q4 next year.
My gut, given those timelines are about what I expected to hear. My gut is for 4.4s, in order to get it out ASAP, we need something, like anything, literally. We need some way for people to be able to download the history. There are very easy solutions to this, like just one big torrent file that has everything up until January 2022 or something, and that solves like 90% of this problem, or 99% of this problem for a year at least, because if the expiry happens after a year, that buys us 1 year by just having, and if Portal Network's done by the end of that year, then we don't need to do anything else. Like we can just have one single torrent file that, is a solved problem that buys us a year for Portal Network to finish. And if Portal Network's not done in a year, you just do another torrent file, like do a second one. I'm hesitant to spend like a huge amount of time engineering some really complex solution to downloading history that's just going to be replaced by the Portal Network in 12 months. Like that's my biggest worry, is that we are building two things, one of which we need right now, and one of which is much, I think everybody agrees, someone correct me here, that is the best long-term solution, which is the Portal Network, because it's fully decentralized. That you can pull individual blocks. You don't need to get all of history at once. It works for both archive nodes, and it works for like clients. Like it solves everything at once. And so I think long-term we want Portal Network. Short-term we need something so we don't have to wait for a year for 4444.
So is there a world in which we have both? Because it kind of seems like to me they're almost addressing different issues, right? Like there's just very separately 4.4s is saying, here's the history. How can we pass it around to whoever wants it? And almost a layer on top is the Portal Network, right? Because you still have a question like, how do I bootstrap a Portal Network node?
So I think that,
do I just rely on peers in the Portal Network?
Yeah, so I think once Portal Network is done, you bootstrap a Portal Network node by just connecting to the Portal Gossip network and just start downloading. It's like a light client may say, I only want block 4,322,000, whereas an archive node may say, hey, Portal Network, start giving me all the blocks from 1 and start counting up. And I believe Portal Network can solve both of those quite well. The caveat is I do suspect that no matter how good Portal Network is, a single giant BitTorrent file is going to be faster. If you do in fact want to sync 8 years of data, a BitTorrent is, I don't see any solution that's going to beat out BitTorrent for speed. That being said, again, from an engineering standpoint, it's expensive to build a solution. And if Portal Network, does good enough, and we have all of history in a BitTorrent up to January 2021 to bootstrap from, I'm hesitant to sink a bunch of engineering effort into two solutions that overlap like 80 or 90%.
Can I suggest a straw man option here? Because Micah, I agree with you. I think everything you said there is, at least my sentiment is mirrored there. So a simple solution here is either go real simple and don't invent anything new here, and we bootstrap a couple of torrents and we're done. It's like quite easy. We have to, come up with the, some way for everybody to agree that yes, these are the torrents, and yes, we're happy to, hard code all of these. What are we talking about? Magnet links or whatever the hashes are that commit to the data in the torrents, and that's super easy and straightforward and boring and does a good job of doing what it's supposed to do. And in theory, does still allow all of the other stuff that we want, which we talked about with SSD data structures, being able to index into it and grab specific ones. Turns out you can do that with torrents too, if things are split up across a couple of files and things like that. And maybe the files within the torrent are blocks of, 1,000 things at a time encoded with SSC. And all of that seems like pretty uncontroversial and straightforward to implement. And then clients need to support ingesting this stuff, which means embedding a torrent client and being able to process the data files. So the work here, like we could bike shed over the format and stuff, but the work here is somebody to sit down and just go ahead and write that down and bang out a proof of concept for it, right? Like, I guess what am I missing? Like where's the point of contention there in that proposal? A torrent full of big files that are SSC encoded, full of, you know, whatever data it is that we're embedding in here, and they're available for download, and we have a bunch of people who seed them.
So
What are
I
we missing?
think that
solution.
is, I don't think you're missing anything. I think that's aligned with at least how like George and Matt and I have been thinking about it. The question, I think the conversation we were just having was like, how does that align with something like the Portal network? Because then we have this question of just a second ago of like, are we somehow duplicating engineering efforts? Like, if we're on board with like moving forward with this like torrent idea for like the year to 2 year mark, and then, you know, once the Portal network comes online, we can reevaluate. That's fine. Do we consider it wasted work if we do build out this like quote torrent client everywhere, or at least in some clients?
I don't think that the clients even need to embed the torrent client. I think that you download the files using a normal torrent client, and then you point your client at the files when they're done downloading.
So does this, so yeah, Marius basically said he might not like the torrents. Do you want to chime in, Marius, if you can?
Yeah, so
because I think what Piper said generally makes sense to me, but
yes,
let's see if there are other options.
I don't see us dropping history without any like really trustless and decentralized and reliable way to get the data. And I don't see torrents as really reliable, and I also don't see as like getting blocks out of protocol as a reliable way to really know that this history will always be there.
Why
Are you saying
do you
you
consider
won't
it less?
drop? Sorry, I just want to ask really fast. Are you saying you're not going to drop historical data that clients already have, or you're not going to implement 4.4s, i.e.
No.
stop serving?
Yeah, I think like
you will continue serving until there's a decentralized way of.
I believe so. Like
I mean, that's
of course I cannot make the decision myself, but from my point of view, I would not drop the requirements for the protocol.
Marius, I would push on that quite hard, because torrents are decentralized peer-to-peer infrastructure that are more or less robust.
I'm not disputing the decentralized fashion of torrents. I'm disputing the reliability.
I think
cool. So hold on a second, because I want to poke on that, because that reliability piece I don't think holds up either, because right now that's already starting to show up in the existing peer-to-peer network. We've got clients starting to drop historical receipts and not serve them. So this is already a thing that's showing up, and a torrent that has one reliable peer seeding it is still available. And this is something that we can absolutely sick the community on, and that people will just perpetually host it for a long, long time very easily. So I just want to challenge that idea that it's not reliable, because we can definitely make the torrent solution reliably available for the next 10 years without problem.
Well, I think we can. I think we specifically can argue that torrents are more reliable than the current Ethereum gossip network. And the reason for that is because it's much easier for a person who just wants to help out and they have a bunch of disk to serve a torrent than it is to run a full client. And so it basically allows us to separate out the, hey, I've got a bunch of disk, but I don't really want to run a full Ethereum client. I'm going to just serve this data, and you can serve that off of a hard drive, a spinning disk, for example. You don't need an SSD or an NVMe drive. You can just have some old spinning disk you had from 5 years ago, put the torrent on it, and seed it to the world. And so I think that my argument is that, well, I can see the argument for torrents aren't reliable. I would argue that they are more reliable than the current Ethereum gossip network for storing, for serving archived state.
What is the incentive would be for anyone to altruistically, altruistically just serve this kind of blobs data?
We have evidence that there are at least 9,000 plus altruistic nodes existing on our current peer-to-peer network that are serving this data right now, who are running nodes for whatever reason, right? Like those are not all miners. And
right. This is the cost of running a node currently. So you have to do this, but otherwise it's just.
I'm running five different Ethereum nodes with no actual like personal benefit at all.
So I think I will agree with Mikhail here a little bit in that Geth specifically, I don't believe has an option for not downloading and keeping old state. The other clients, like Nethermind, for example, just has a command line flag where you can just say, no, I'm not going to store it all. And a lot of people who run Nethermind do not serve the data. And so I think there is an argument to be made that it's not altruism so much as laziness. Like it's, if you have some need or reason to run an Ethereum client, and for whatever reason you choose Geth, because everybody chooses Geth, by default, unless you do a bunch of work, you're going to serve all the old data. Whereas if we switch over to a torrent, those people who are like, oh, I want to run an Ethereum node, but I'm not going to go out of my way to be an altruist, those people will stop serving. And so we will reduce from lazy plus altruists to just altruists with the torrent option.
And this is why I like the idea of having a new protocol, a new networking protocol that achieves this. So basically, like retire the history retrieval from the current ETH protocol, implement ETH 68 or 70 or whatever, and create a new networking protocol that is only there to serve these old states, and then we can build nodes that just serve these old states. We can build our own torrent network, and we can have even a node to implement both networking protocols.
That seems definitively worse than a torrent, because if nodes have the option to be part of or not part of that network, then it's the same concept as opting in or opting out of a torrent. Nodes are wanting to get rid of this data, so being part of that history network means keeping the data and serving it. And so now you're relying on not just anybody who wants to host a torrent and serve it, but only people who want to host an Ethereum node, which with all of the complexity and heaviness that involves, plus the history data. So that seems like on this, at least seems like it's worse than the torrent solution in terms of reliability and people using it.
And then for example, Portal Network could tap into the same protocol and serve the same blocks on this protocol, and we could have.
We're not going to do that though, because we're not going to get on Dev P2P. The Portal Network is explicitly like on its own separate like networking protocol on top of Disk v5 for specific reasons. So
yeah, but
if you want to build a separate network for storing and serving all the history data, we're doing that. It's called the Portal Network. So if we want to solve this with that, then let's do it that way, because we're already like way far down this path to build a decentralized network that serves the history. But if we want a simple solution that serves big blocks of the history, let's use boring solutions that are already well known and understood, and do it that way.
Yeah, and I agree. I agree about that, but I'm just saying that I'm not comfortable dropping our requirements before we have this decentralized solution. Like I agree that we can build it, and we can use we can do the BitTorrent thingy or whatever torrent we want to do, but I'm not comfortable merging the pull request to drop this historical states before we have some our own version of it.
Okay,
And this
so
the
is there
problem.
somebody from the Geth team who wants to start building out a portal client in the Geth code base? Because that's the solution for that, right? Like, I'm being a little like pushy here. I get it, but like if the only way that I know that you're not speaking for the Geth team, but if the only way that like you're comfortable, you know, accepting 4.4s and dropping this data out of the client is to have an owned decentralized peer-to-peer solution for this that looks something like the Portal network or is, you know, on one of our peer-to-peer networks, and you want 4.4s to happen, then the answer to that is prioritizing work on actually building that thing out.
Yeah, right now we're prioritizing work on the merge, so like we have our hands full with this. But yeah, I think that Scholt is interested in doing something like this. I'm not sure if, like, we haven't really discussed 4x4 in the team yet, because we have been focusing on, in my opinion, more important topics.
Yeah.
But yeah, I agree that Geth building a portal client, at least on the history retrieval, on the history network, would be very important.
Okay.
So I think we're about to hit the time that we had scheduled. So I think the takeaway here is that we need to probably better understand, you know, maybe do some more legwork to understand like what's an acceptable solution on what timelines. Does that sound good?
I posted this thing in the chat where this EIP tries to solve 3 different problems. I'd love those problems to just be solved separately. So first we have import functionality, then we have distribution of data, and then we have the final removal of from the default, where we don't serve historical state anymore. I think 3 is like the final goal of 4.4s, but I think we should have 1 in advance, and I think 2 it's getting a little bit heated, and to keep moving, at least start with 1.
I think 4444 only specifies 3 at the moment.
I don't know what EPED is. We have one that's called 4444.
EIP-4444 is the...
I'm just being difficult.
4.4s is the correct pronunciation.
Yeah. It is not 4.4s. Anyone who says 4.4s is wrong.
Anyway,
Strictly wrong.
At the beginning of the meeting.
What I got from the last point, where we want to remove the historical data serving, is that we cannot warrant this removal. We cannot trust it until we have solved 1 and 2.
Yes, I agree. I agree with that. I do think that we need to solve 1 and 2. I just want to be clear that the EIP itself is only solving 3. It's just, one can argue that it will never pass all core devs without 1 and 2 being solved separately already. Like we need someone to write 2 more EIPs basically.
Yes, so let's try and solve 1 and 2. And I think 1 is really simple. 2 depends on either a portal network or a torrent client or something else. But we should look at solving these things, and then we can clear up 4.4s to move on.
Yep.
Yep.
Okay.
Sounds
Good
good.
talk, guys.
Right.
Yep. Thanks everybody for coming. I'll post the recording for this on the GitHub issue and in Discord, and you know, we'll just keep the conversation going. Yeah, we'll try and synthesize what we talked about a little bit. I think we had some good discussion about how to solve one. And so maybe we'll try and write something more concrete up about that. Sounds good?
Yep,
Sounds
sounds
great.
good.
All right.
Thanks, everybody.
Thanks, everyone. Talk to you soon.
Yeah, thanks for joining. Bye, everyone.
Bye.
Bye.
All right.